Hello, my name is Joanna, and I am joined by Xander and Manny. We are very excited and proud to introduce to you our Capstone project, Shttl. Shttl is a portable spice dispensing system. We found that in the process of cooking and baking, storing and using spices can be both messy and tedious. We saw a use for a handheld storage system that allows for accurate measurements to be dispensed at the touch of a button. Our project mainly combines hardware and software areas. Our physical assembly required and featured the use of CAD to prepare our 3D printed design. Our custom PCB design pairs with a complex wiring system, and the device is powered by a Raspberry Pi. On the software side, our device features a multi-threaded program to handle asynchronous inputs and multiple outputs. We will dive deeper into these topics soon. Our design approach featured the following requirements. Although our MVP was to handle 2 spice compartments, we managed to complete and integrate all 6. Our testing metrics, which will also be discussed in more detail later, required us to focus on accuracy, size, and ease of use.
Now I'll talk a little bit about our block diagram, and as you can see, we have 4 sections of our block diagram: the user interface, the input stage housing, the control stage housing, and the storage and dispense. Starting at the user interface, we have the e-ink screen, which displays the names of all the spices and the percentages of all of the remaining amounts in each compartment, and then the selected amount of spice that you want to dispense. And that will be controlled by the rotary ring, which is an input from the user. The user could spin the rotary ring, and then the e-ink screen updates as the rotary ring changes to pick the proper amount of spice. And then each around the entire device there are 6 buttons, one corresponding to each compartment, and you push a button to dispense the selected amount of spice of that compartment. And going on to the input stage housing, this has all of the inputs to our Raspberry Pi, and all of these inputs are routed using a PCB. In the input stage housing, we have 6 IR distance sensors, and that is used for calculating how much is left in each compartment. And we also have the ring selector, which is a potentiometer as another analog signal. And since we have these 7 analog signals and the Raspberry Pi only takes in digital inputs, we need an analog to digital converter, which is what is seen in that last block. And then all of that is fed back into Raspberry Pi through the SPI interface. I just want to include that the wiring inside the input housing stage was very intricate because it had 6 different IR sensors, the potentiometer, and all the wires for each button. So there were a total of about 50 wires just in that section. So now in the control housing stage, this is the whole central processing unit of our device, and that is the Raspberry Pi Zero W. And this is powered by the Pi Sugar module, which is designed specifically for the Pi Zero W, and they could stack on it right on top of each other. In addition to the Pi Sugar, we also stack 2 additional motor bonnets, which are capable of controlling 4 different motors, and they communicate through the I2C interface with the Raspberry Pi. And all of these modules are stacked on top of one another to save the most amount of space. The Raspberry Pi Zero W is controlled by a multi-threaded software, so it could handle asynchronous inputs and drive multiple motors and screens. So now going on to storage and dispense, the Raspberry Pi Zero W communicates to the motor controllers using PWM, and then motor controllers are able to drive all 6 DC motors, which were originally servos that we modified to take advantage of the DC motor with the gearbox to give us enough torque to actually turn the dispense mechanism. In addition to the 6 DC motors, we have 2 fans that are intended to provide airflow to the device mechanism so it could disperse the spice as it's being released. And lastly, I'd like to mention that this part of the device detaches from the control housing stage. So in order to maintain electrical connection from the control housing stage to the motors, we used pogo pins and copper tape that so when 2 sections are in contact, we have a secure electrical connection.
CAD models of Shttl. As you can see, it's in a cylindrical shape, and I will walk you through each component. The black thing on the top is e-ink screen. We chose e-ink over OLED because e-ink, when it's not updating, it actually consumes very, very little to none power. And the downside of using an e-ink is that it takes 1-2 seconds to refresh the screen. The yellow ring is a selection ring. The user will use it to select which volume to dispense. And then these are the clamps that hold the upper and lower stage together. And then at the bottom, if we flip under it, you can see the entire center section is hollowed up for the airflow, for the fan to install and for the airflow to come down. And now I will take this apart. If we take this apart, as you can see on the top, we have our electronics. The red are the motor bonnets, and the blue is a battery controller. This gray box is our battery. And then the Raspberry Pi is right here. They're all vertically stacked together. You can't see it in the exploded view, but they are. And then the yellow thing is the ring selector. And if you go down, these pogo pin holder, this little cube on the side, will line up with these slots to provide us electrical connection to the motor. There are six of the connectors. And if you go down, this is we have 6 individual dispenser, each driven by a modified servo acting as a DC motor and with a very high ratio gearbox. And then we have a gumball wheel in each one of these dispenser to actually dispense it. The gumball wheel, while rotating, will have spices spill out the front, which will drop through the hole in the center. And yeah, this is Shttl.
Now I'm going to talk about the actual physical device where we built. So as you can see, it's pretty similar to our cat model, and we have 6 buttons. Each corresponds to a spice chamber, and then we have the e-ink screen on the top, displaying like the current amount selected to dispense, and also the remaining for different kind of spices. And then this is the ring selector that we are using to select different dispense volume. As you can see, when I just rotate it, it will jump to the next one, and then when I rotate it again, it will just keep selecting the next one. And then we compute based on what you select. We convert that to a time that we drive the motor. For example, we loaded up the spice chamber 4 and 6. So now I'm gonna try to dispense the 1/4 teaspoon. As you can see, when I press the button, a little bit come out. I'll just do it again. Just a little bit come out. And now I'll switch it to 1 teaspoon. The e-ink screen takes a little bit to refresh, but it does, as you see, as I rotate it this way, it switched to 1 teaspoon, and I'll press it again. See, a lot more came out. See, that's like 4 times more than we had before. So yeah, that's the basic operation of it, and now I will take it open to show you the inside. So we use Velcro tape to hold the upper and lower assembly together. And as you can see, these are the 6 receiving end of the pogo pin connection. And if you turn this device around, you can see the actual pogo pins. That's the driving the motor. That's the electrical connection for the motor. And here we have the fan in the middle, 6 IR distance sensor to measure the remaining in the system, the remaining of each spices. We do not measure them in real time. We have a slight delay, so if you leave it there for like 30 seconds, it will automatically update. That's because the e-ink screen update will block all other functions, so we don't want to do that too often. And then, as you can see, we have some spices loaded in there, in 2 of them, and we just tried this section with, I think it's some sort of pepper. And yeah, that's the basic operation of the Shttl.
As mentioned before, our main goals were to be accurate, portable, and easy to use. We based our size measurements off of a Starbucks venti cup in order to guarantee the device is handheld. We also wanted it to be lightweight, and although we had to increase the weight past the original goal, it is still highly portable. We achieved a consistent dispense accuracy within 20% of the target, which makes this the main goal that we did not end up having enough time to meet. As an aside, we had originally intended to measure on the order of teaspoons, but underestimated a teaspoon's size, so we ended up scaling down to measurements on the order of 1/4, 1/2, and full teaspoons. The device has a long battery life and is quick to charge, meeting our requirements for both metrics. For dispense speed, we needed to slow down our dispense in order to accommodate a better accuracy. The spray diameter was smaller than intended, which is actually a happy accident for dispensing in small bowls, but would not be sufficient for spread out seasoning. Lastly, both our noise level and jamming rate met our requirements of under 60 decibels and once per month, respectively.
Lastly, I just wanted to introduce the team. Again, I'm Joanna, this is Xander, and this is Manny.
And thank you so much for watching.
And hopefully one day you guys will all have your own shuttle.